So far in this unit, we've been looking at proofs for segments and angles. And in these next two videos, we're going to be looking at relationships between lines and relationships between lines and angles. So in this first one, let's look at parallel lines. We know two parallel lines are parallel if they are coplanar and do not intersect. I really want to make sure you understand that parallel lines must be coplanar and they never intersect. All right, parallel planes are planes if they do not intersect. Okay. And then this new word that you probably have not heard of is called skew lines. Skew lines are two lines if they are skew if they are not coplanar and do not intersect. So very similar to parallel, but they are not coplanar. I want you to imagine if you think about highways and overpasses. Let's say you have a highway going this way, and then underneath it, there is a road going underneath, and that blue one is going over the top of it. Okay, so even though when I'm drawing it, it looks like those roads intersect, one is really on top of the other. So this one is like a bridge, so it's tall. It's above each other. So these roads will never intersect, but they are also not coplanar. All right, so I could not draw one single plane that contains those two lines. So let's look at another example. So in this diagram, we're going to see which lines appear to fit each description. So we have in part A, parallel to AG. So AG is right here. So we want it to be parallel and also contain C. Okay, so the only line that's parallel to that and has that C would be this one right here. Now, if I didn't have to put it through C, there would be many lines that are parallel to AG. I could have BH. Do you see how those two lines will never intersect, but they are on the same plane, that top plane? All right, you might think, well, CI, that doesn't have the same plane, but if I were to connect them with a plane like that looks like that diagonal plane, then they would be on the same plane. They would be considered coplanar. So all of these lines that are going in the same direction, those are all going to be parallel to AG. All of those would be considered parallel. All right, let's look at B. So perpendicular to AG and contains B. So here's AG, and we want it to be perpendicular and then contain B. Here's B. So perpendicular means at a right angle. Now they didn't really draw in their 90-degree angles, but these are going to be meeting at 90 degrees. So like this is flat and then that's flat. So we would say that this line is perpendicular to that, even though when it's physically drawn, it looks like a non-right angle. All right, so that would be a line that is perpendicular to AG. All right, same thing with, well, we'll leave it at that. What I really want to worry about now is skew. Skew to AG and contains C. So skew would mean that they are not coplanar. So here's AG still, and it contains C. But if I were to extend this green line, all right, you see how this kind of looks like highways. If these would never intersect, even though it looks like they're intersecting, you have to think three-dimensionally. And maybe we can do more of this in class so you can see some three-dimensional objects and what would be considered skew. But these never intersect, but they're also not coplanar. I can't draw a line like I can't draw a plane like I could with the parallel one. All right, so then the last one, name the plane that contains C and appears to be parallel to plane AFL. Okay, so let's color in plane AFL. AFL. That's this one right here. The plane that we can't really see, it's on the outside. All right, so we want the plane that contains C and appears to be parallel. So if it's parallel, then the edge, see how the edge of this is AF, then we need something that's parallel to AF. So those are both edges that are parallel to each other, and that would make this whole plane parallel. Okay, notice that that back edge right here is also parallel to IJ. All right, so again, if you have questions on that, we can do some more 3D objects in class. So then the last thing we're going to talk about is the two postulates, the parallel postulate, if there is a line and a point that's not on the line. So we're talking about P. This is my original line. Then there is exactly one line through that point that is parallel. So I can only draw one single line that has to be parallel. What I want you to notice is how they're labeling parallel. They have these arrows, and they're different than the arrows that show that the line continues on and on. These are like solid arrows, and that indicates to us that these are parallel. Okay, so there's only one line that I can draw through that. If I drew any other line through point P, those would not be parallel to that original line. And then the same thing for perpendicular. There's a perpendicular postulate. If I have this line L, all right, and I have a point P, then there's exactly one line that I can draw through that point that would be perpendicular. Any other line that I draw through that won't intersect line L at 90 degrees. So this is a short video. We'll do, please watch the next one for more relationships between lines and angles.